Thank you all for coming today, and hope you enjoyed your little break. We are going to continue on, pressing on with some really great content for the rest of the morning. And so I have the pleasure of introducing Maitê Alves Bezerra from Informa. She's this software-defined vehicle principal analyst at the software-defined vehicle Informa Tech Automotive Group. Wow, that is a title. Exhausting saying it, but it's great. She's obviously well connected into the software-defined vehicle industry, which is where COVESA increasingly is moving into with BSS and with all the other things that we're doing around connected vehicles. So we're excited to have Maitê here. We're excited to have a special growing relationship with the Informa team that are represented here today, and we're looking forward to a great June event in Detroit, the first week of June with the Informa Auto Tech Detroit week, and that will be there. COVESA will be there also. So if you're from Detroit area or the U.S. and planning to go to Auto Tech Week, make sure you check in with me, and we'll invite you to our special reception that evening, the first night of the event, and we'll look forward to that. So Maitê, why don't you come on up, give her a round of applause. We'll look forward to what she has to say.
Thank you. Thank you very much. All right, so thank you everyone for attending this session. So yes, my name is Maitê Bezerra. I am a principal analyst in software-defined vehicles, and today I'm going to talk about software-defined vehicles. I'm going to give you an overview on what this concept is, what is the current state of the industry, and I'm going to show some of the results of our Wards Intelligence SDV survey. So, let's dive in. I think a good starting point for this presentation is the definition of software-defined vehicles, so SDV for short. And that's because even though there is a consensus that this is where the automotive industry is moving towards, we still don't have a clear-cut industry definition of what that actually is. Having said that, I am seeing a few companies starting to use a common definition as any vehicle that manages its operations, adds functionality, and enables new features primarily or entirely through software. But I really would like to dive into the specifics. So what actually makes a vehicle software-defined? First of all, these vehicles, they have a very sophisticated vehicle architecture, in which the ECUs are consolidated into domains, or you have a zonal architecture with one central computing or two central computings and a zonal processors in the 4 zones of the car. But the main point is that these domains or these central computes, they are running on high-power computes, so HPCs. And these HPCs, they are capable not only of processing a large amount of data or processing robust AI-based and machine learning algorithms, but they also have computing power and memory overhead to receive new functionalities and new updates during the life cycle of the vehicle. That would be 10+ years. Another specific point of these vehicles is that all the vehicle domains or vehicle functions are connected to each other. So then the vehicle system is capable of understanding exactly what is happening in the cabin and in its surrounding. These vehicle domains are also connected to the cloud. So then you have a very intelligent system that is able to understand its environment and the cloud and react to it. So then you can achieve new levels of user experience and safety, for example. Another important point in here is that because these domains are connected to the cloud, the OEMs are capable of monitoring, controlling, managing, updating, and upgrading these vehicle systems remotely. So they can also gather data from these vehicle domains and understand how the vehicle is being used, what actually delivers values to the customers, and improve their services during the life cycle of the car, or even create new services. They can also use this data to understand if there is a potential upcoming failure in the car and fix it before it happens, or even if it is already happening, you can already do some recalls over the air as well. So you don't necessarily have to take the car to the dealer every time there is a problem in the car. But I think there are 2 points about SDVs that sometimes are overlooked. First, these cars are not just cars that can receive OTA updates. I mean, there are several IoT devices today that have OTA updates, and they are not software-defined. The characteristic here is that most of the vehicle functionalities, some say 80% of vehicle functionalities, will be driven by software. And what that means is that you can actually change the nature of the hardware during its life cycle through updates. So you can go and buy a vehicle that is capable of assisted driving, for example, so L2, based on the SAA automation level classification. And then 6 months later, you buy new functionalities, and you upgrade the automation level to L2 Plus. And then 2 years later, you buy new functionalities on demand, and you upgrade your car to L3 automation level. So you are basically changing the nature of what the sensors and basically the hardware in the car is doing remotely. So this is a very important point. And a second point is that to have a full SDV, you need to have a full decoupling of the life cycle of each vehicle functionality from other vehicle functionalities, from the software platform, and from the hardware platform. So that every time the OEM releases a new update or a new feature, that new piece of software is compatible with the vehicles on the road. So I think a good analogy here is really the iPhone, because Apple really achieved the software-defined moment with the iPhone. You know that today, if you buy an iPhone 8, for example, that was launched 5 years ago, you know that you will be able to download the latest version of iOS. You will have exactly the same version as someone that bought the latest iPhone. You will also be able to download the same applications. So what Apple achieved is the full decoupling of the software lifecycle from the hardware lifecycle, meaning that, and that's exactly what OEMs want to achieve, that all the vehicles on the road are compatible with the latest version of software. That is very challenging, by the way, but that is the ultimate goal that we are expecting to achieve with this SDV future. So that is challenging because that is very different from what we have in vehicles today. So this transition to SDV is not something that is going to happen overnight. It will be incremental. So that's why it is starting with what we are calling at Words Intelligence as semi-SDVs. So the starting point of SDVs really is the consolidation of the electric and electronic architecture in the car. You start consolidating these ECUs into domains. They're going to run into these powerful SoCs. So then you are able to create abstraction layers, and then it's much easier for you to scale your software. And we are seeing these cars having consolidation in the infotainment domain and in the ADAS and autonomous driving domains. These vehicles are not SDV yet, because to be an SDV, you will have to have a full domain architecture, so the whole vehicle connected to this new platform. But they do have already some level of upgradability in these domains that are consolidated. And we're already seeing these cars on the road. And as you can see with this forecast, we are seeing that the sales of SoCs that are going to be used in ADAS and autonomous driving domains and cockpit domains are going to increase exponentially around 2026. So around that time, we are expecting to see a much higher number of these SDV, semi-SDVs on the road. SDVs we will still see, but in not as much as we will see semi-SDVs, because as I said, this is going to be an incremental change. Here is just comparing what is a semi-SDV and what is an SDV. I explore most of the parts in regards to the vehicle electric and electronic architecture. I think one thing that is important to point out is that in a semi-SDV, you haven't really reached this level of software and hardware abstraction, this full level. The software is still coupled with the hardware that you have in the car, whereas in an SDV, you have the full decouple. Also, as I mentioned in the SDV, you have the vehicle functions talking to each other. So therefore, you need to have high speed and reliable in-vehicle networking, vehicle communication. So in SDV, we're talking about high speed in vehicle networking, but in semi-SDVs. But in SDVs, we're talking about multi-gig in vehicle networking. And in terms of the automation level, in semi-SDVs, we usually see these vehicles going up to L2+, whereas in a SDV, they kind of start in S2+ and move onwards. But here is important to highlight something. I'm talking about what the hardware in the vehicle is capable. It doesn't mean that the vehicle will be capable of L2+ automation when you buy it. It just means that the hardware is capable of it, but the functions will be developed later, and you will be able to download or buy them. And that's actually the main point about SDVs. It's all about over-provisioning from what you are going to develop in the future. Most of these features, they are not even developed yet. The codes have not been written yet. But the idea is that you have robust enough hardware to receive these functionalities in the future. So, in order to understand this SDV transition, we applied a survey to the automotive industry, and that includes OEMs, Tier 1 suppliers, Tier 2 suppliers, dealers, consultants, everyone working with vehicles. We applied the survey in December last year, and we got 168 answers, and I'm going to show some of the results. So, we asked in our survey, where is your company in the SDV journey? And most of our respondents, but as you can see by the results, they already passed the planning stage, but only a few are in the production stage. So really, most of the companies are today in the development phase or in the investigation phase. And that really shows that this SDV transition is something that is ongoing at the moment. It's happening now. We're not going to see a lot of SDVs next year or in the following year. It's something that is going to take time. We also asked our respondents, which OEMs you think are best prepared to adapt to this new SDV concept and business models? And as you can see by the results, most of the respondents believe that the EV or BEV startups are best prepared. And the reasons for that is, first, these companies, they are digitally native. They're being created now. They are agile. They have a large base of software talent, and they don't have legacy. They don't have vehicles being built in distributed architectures. They are building vehicles now. There is no point of using a suboptimal architecture. So these companies are already building cars with domain architectures and even zonal architectures. These companies are already deploying semi-SDVs and SDVs today. They are collecting data, they are improving their algorithms, they are testing business models, they are seeing what the client wants, they are learning. So they are a step ahead in this journey to SDVs. Also, there is something that they have in their favor, which is this high-tech brand association with their name. So the customers that buy vehicles from these brands, they are tech-savvy. They are okay in receiving a vehicle with a software that is not final. And they are okay in testing the software and providing feedback to the OEM and helping the OEM to improve this platform that they are offering. Whereas that's not always the case with the traditional car buyer. So I think as we can see in here, the legacy the traditional OEMs have is an obstacle, at least in the starting point in this SDV transition. That doesn't mean that they are not going to be able to transition. That just means that the beginning will be a bit more difficult. The BEV startups, they have an advantage. So when will we see at least 50% of all new vehicles being sold with this software-defined architecture? Most of our respondents, oh, it works, okay. So most of our respondents believe that this will happen between 2028 and 2029. However, what I think is very interesting, when you look at the results by respondents and you see what OEMs are saying, they are less optimistic. They actually believe that this will happen after 2030, and some of them believe it will happen after 2032. And that really shows how they appreciate how complex this transition is. So, who will help OEMs in their journey? I think we heard many companies, tier 2 suppliers, SoC suppliers saying, well, after the SoC shortage and because of SDVs requiring these HPCs, they are saying OEMs understand how important SoCs are now, so they are doing business directly with us. They understand the HPCs to be critical, a critical piece, enabler of this SoC transition. So they're not talking to the tier 1s anymore as they used to. They're closing deals with us directly. We heard some similar story from tier 2 software suppliers as well, saying, well, now that we have abstraction layers, I can easily integrate my applications into the vehicle platforms. I don't necessarily need an integrator. So then OEMs are coming directly and talking to me. So then many people start asking, what would be the role of the tier 1 there? What is happening? So then that's why we asked our respondents, who is going to help OEMs in this journey. And surprise, surprise, the tier 1 suppliers. So yes, the scope of what they are doing, of the activities they do is decreasing. Perhaps they're doing activities that are less profitable than before, but they are still very important. And I think one thing that is very interesting about this result is that 35% of our respondents think that the transformational supplier will actually be the cloud company providers. And that's very interesting because even though the hardware, the SoCs, they are the key enabler of SDVs, the value creation is actually happening in the back end, where you analyze the data from the vehicle, you gather insights from it, so then you have the knowledge on what to offer to your customers. But also, when you think about competitiveness in the future, it will be related to the companies that are quick in understanding what the customers want, develop software, and deploy the software in the car. So that's why we are seeing a lot of OEMs now talking about cloud-native software development and engaging partnerships with companies like AWS, Google, or Microsoft. Vertical integration. Okay, so a few years ago, we will hear OEMs saying, we want to control nearly everything nearly all the aspects of our vehicles. But then, in the past 1 to 2 years, this narrative is kind of changing. OEMs are starting to realize that you can't develop everything and be good in everything that you are developing. There are loads of parts of this vehicle architecture that you already have standards. You have partners that are actually better than you would be in developing that technology. So then, we asked in our survey what OEMs would want to control with their proprietary knowledge, what aspects of the SDV architecture they want to control, what aspects it would be developed in collaboration with partners, and which aspects the partners are expected to control. And as you can see, OEMs are expecting to collaborate in most of the aspects of the SDV architecture. I think collaboration is being key in this SDV future. Before, you will go to your supplier, ask, I want an infotainment that does this. You will receive the silver box, and the relationship will end until you had a new vehicle platform. Now we are talking about an ongoing collaboration between OEMs and their suppliers, because when the vehicles is sold is actually when the collaboration starts, is when you start gathering insights and you start improving the vehicle functionalities. So then you have a complete change in how the supply chain is going to work in the future, and collaboration being key for that. However, as you can see, the OEMs still want to have control of the vehicle software platforms. But that is also very interesting, because we heard a few OEMs saying that they are developing their vehicle OS, or automotive OS. But even that, it seems that they're coming to the realization that this idea of this automotive OS, the abstract, this complex network of virtual ECUs, is actually very complex. So it is a software piece that is composed of several software layers, and some of these software layers are non-differentiating. They do not deliver value to the final customer, and they are very expensive to develop and to maintain. So we are seeing OEMs starting to realize that as well, that there are some parts of the software platform that, yes, they must maintain ownership, but not all of these layers. But the input I am actually having from the industry is that even though OEMs are starting to realize that, it seems that there isn't really an agreement in what layers are deliver differentiation and what layers doesn't. So I think this will be the next challenge now, to understand what are these layers that should be standardized and which shouldn't. Relationships must improve. So I'm talking about collaboration being key for SDVs. So what we wanted to understand from our respondents is, what are the main obstacles for OEMs to collaborate with their suppliers? And the result shows that the main obstacle is the conflicting demands between ICE technology, so legacy technology, and new tech technology, which is not surprising because you have a complete different mindset, right? You are changing from give me the cheapest SoC you can have and give me the cheapest silver box to I want to over-provision to deliver features during the life cycle of the car. So that makes sense. But what I think is very interesting is when you look at the results by Tier 1 and Tier 2 suppliers, what they think is the main obstacle to collaborate with OEMs is actually the lack of competence in software and data processing and the company mindset and leadership. And that, again, comes back to legacy. OEMs are not software companies. They were not. They are transitioning now, but this is something new to them. And also, they had this old way of working. So you had departments that wouldn't talk to each other. You have information legacy. So someone from infotainment development wouldn't talk to someone from ADAS development, for example. But now, you have a vehicle architecture in which the vehicle functions are connected to each other. So you have to mirror that in your organization as well. You need to have cross-functional teams. Also, you need to change your mindset in not being so cost-centric to understand that you need to over-provision, that you need to prepare for the future and what your car is going to receive as new software and functionalities. So this is something that OEMs really have to keep in mind to improve their relationship with their partners. Okay, so we asked our respondents which infotainment OS will become dominant in 2025, and I think it's unsurprising that many respondents said they will be Android Automotive OS. We saw many automakers migrating to it. It's a turnkey solution, for the basic infotainment functions. You benefit from the well-established user interface that Android has, and also from the large software community. What I think is very important in here is that a large number of respondents said other, and they say Apple CarPlay. And I think that shows that there is still a not clear understanding on what is an embedded infotainment system and what is a smartphone mirroring system. So Apple CarPlay doesn't run in the car, it runs in the iPhone. So it's not going to become a leading embedded infotainment system. Some respondents also said Apple iOS, which is quite interesting because Apple hasn't really focused in abandoning iOS in infotainment systems. They had a partnership with Porsche in trying to have a higher integration, but really isn't their strategy at the moment. Even the latest CarPlay launch, in which you can see the Apple running in the cockpit of the vehicle, in the cluster, that runs in the iPhone. And the feedback I got from that is that they are really focusing on an iPhone-based experience. So I do not expect Apple and iOS to become dominant, not at least until 2025. Okay, so we also asked our respondents about the top priorities for SDVs, and overwhelmingly the results show cybersecurity. Again, not surprising. Vehicles are now connected. You are using third-party applications. You are using open-source OS. You have all the vehicle functions communicating to each other, including mission-critical functions. So, of course, your attack surface increases, so cybersecurity becomes a major problem. And, of course, in Europe, we have upcoming legislation as well, the GSR. So that result really isn't surprising. The second top priority is future-proof architecture. So again, you have a vehicle that will be compatible with the latest software during its life cycle of 10 plus years. But in the other items, there wasn't really a consensus between the companies. So Tier 1 and Tier 2 suppliers, they see reliable sensors as the second most critical SDV priority. And they also see V2X connectivity as well, whereas OEMs don't actually agree with that. For them, surprisingly enough, a priority is having strategies to upgrade the hardware in the car during its life cycle, also agile design process, and the access of a thriving application ecosystem. Lastly, we asked our respondents, what is the automotive industry going to gain from SDVs? And the respondents say, timely introduction of new features over the air. And that was the main criteria that everyone agreed upon. After that, we had a few disagreements. So Tier 1s and Tier 2 believe that V2X connectivity will be a gain from SDVs, whereas OEMs believe that the new post-sales revenue stream will be a new gain from SDVs, which the Tier 1 and Tier 2 suppliers don't necessarily agree. But the point that all of the players agree is that SDVs will bring more efficient product development and the enabling of Level 2+ and now 3 automation level. Well, that's it from me. Thank you very much. I spoke for nearly all the time, so thank you for attending.